The universe has just revealed a secret so profound, so utterly mind-blowing, that it's left the world's top scientists reeling. The James Webb Space Telescope, humanity's most powerful eye into the cosmos, has captured an image so shocking it's rewriting everything we thought we knew about the universe. For weeks, the scientific community has been buzzing with anticipation, waiting for a leading physicist to weigh in on this cosmic bombshell. Now that silence has been shattered, and the words spoken are nothing short of revolutionary. This image could redefine the very fabric of existence. Buckle up, because what's been uncovered is a game changer, a heart-pounding revelation that's shaking the foundations of cosmology and leaving us all staring into the abyss of the unknown. What's in this image? Why is it causing such a stir? And why are the brightest minds calling it the most significant discovery of our lifetime? Let's dive into the cosmic deep end and uncover the truth behind this jaw-dropping moment. Picture this: a single photograph, a snapshot of the universe's ancient past, filled with galaxies so numerous they blur into a cosmic tapestry. Each galaxy, a swirling metropolis of over 100 billion stars, stretches across the frame, some so distant their light has traveled for nearly 14 billion years to reach us. This isn't just a pretty picture, it's a time machine, peering back to the universe's infancy, to a time when the first stars were born. The telescope's latest image, a deep-field masterpiece, has unveiled something utterly unexpected: galaxies that shouldn't exist. These aren't the small, chaotic star clusters we predicted for the early universe. No, these are massive, structured, and brimming with stars that look far too mature for their age. The implications are staggering. If these galaxies formed faster and larger than our models allow, then something is fundamentally wrong with our understanding of cosmic creation. The textbooks, the theories, the equations, they're all on the chopping block. Let's set the stage. The universe, as we know it, began with the Big Bang roughly 13.8 billion years ago. In those first moments, it was a hot, dense soup of particles, too chaotic for stars or galaxies to form. Over hundreds of millions of years, gravity pulled matter together, forming the first stars and small irregular galaxies. Or so we thought. The telescope's new image challenges this timeline. It shows galaxies fully formed and teeming with stars, existing just 500 to 700 million years after the Big Bang. That's like finding a skyscraper in a prehistoric village. It defies everything we believed about how quickly the universe could build itself. These galaxies are packed with older, redder stars, not just the young, blue ones we expected. This suggests they had already gone through intense periods of star formation, creating billions of stars in a cosmic blink. The question is, how? How could the universe churn out such massive structures so fast? This discovery isn't just a puzzle, it's a cosmic earthquake. Scientists are scrambling to explain it. Some propose that the early universe was a star-making frenzy, with conditions so extreme that stars formed at an explosive rate. Others suggest exotic physics, like unusual ratios of primordial elements, could have accelerated star aging. But here's the kicker. If these galaxies are as old and massive as they appear, our entire model of cosmic evolution might need an overhaul. The standard story, where galaxies grow slowly, merging over billions of years, might be wrong. Instead, the universe could have been a far more dynamic, chaotic place, with massive galaxies springing up almost overnight. This isn't just about stars and galaxies, It's about the fundamental laws of physics. Something doesn't add up, and the stakes couldn't be higher. Let's zoom in on the telescope itself, the marvel that made this discovery possible. Launched in December 2021, this engineering masterpiece is humanity's boldest leap into the cosmos. Orbiting 1.5 million kilometers from Earth, it's equipped with a massive segmented mirror that collects faint light from the universe's farthest reaches. Its infrared vision is the key. It can peer through cosmic dust and detect light stretched by the expanding universe, light that's been traveling since the dawn of time. Unlike its predecessor, the Hubble Space Telescope, this observatory sees in wavelengths that reveal the hidden secrets of the early universe. Its sun shield, the size of a tennis court, keeps it colder than Pluto, ensuring its instruments can pick up the faintest signals without interference. Every part of this machine, from its gold-coated mirrors to its precision sensors, was designed to unlock mysteries we couldn't even imagine a decade ago. Now, let's talk about what this image actually shows. Imagine a patch of sky so small it could be covered by a grain of sand held at arm's length. In that tiny speck, the telescope has revealed thousands of galaxies, some appearing as faint red dots, ancient relics from the universe's youth. These red dots are the culprits causing all the commotion. When scientists analyzed their light, they found chemical signatures of older stars, rich in heavier elements like oxygen and carbon. This is a cosmic shocker. In the early universe, stars were supposed to be made mostly of hydrogen and helium, with heavier elements forming later as stars died in supernova explosions. But these galaxies suggest heavier elements were already abundant, hinting at a rapid cycle of starbirth and death we didn't think was possible. It's as if the universe was working overtime, forging the building blocks of planets and life in record time. The emotional weight of this discovery hits hard. For centuries, humanity has looked to the stars, wondering about our place in the cosmos. We've built myths, religions, and sciences around the idea that the universe follows a predictable path. Now, this image forces us to confront a humbling truth. We might not know the universe as well as we thought. It's both thrilling and terrifying. Thrilling because we're witnessing a moment that could redefine science for generations. Terrifying because it reminds us how vast and mysterious the cosmos truly is. Are we on the verge of unlocking the secrets of creation, or are we just scratching the surface of an even deeper enigma? The answer lies in the data, and scientists are racing to collect more. Spectroscopy, the art of splitting light into its wavelengths, is the key to confirming these findings. By studying the light from these ancient galaxies, researchers can pinpoint their chemical makeup, their distance, and even their motion. Early results are already raising eyebrows. Some of these galaxies are moving at speeds that suggest they formed in a universe expanding faster than expected. Others show signs of supermassive black holes at their centers, another surprise since we thought such monsters took billions of years to grow. Every new spectrum is like a piece of a cosmic puzzle, and the picture it's forming is unlike anything we've seen before. If these findings hold, they could force us to rethink not just galaxy formation, but the very laws governing the universe's expansion. But it's not just the early universe that's stealing the spotlight. The telescope's gaze has also turned to more recent cosmic dramas, and the results are equally stunning. Take a group of galaxies known as a quintet, locked in a chaotic dance millions of light years away. One galaxy, a rogue intruder, is plowing through the group at breakneck speed, sending shockwaves through the surrounding gas. These shockwaves are doing something extraordinary. They're triggering star formation in ways we've never seen. The telescope's infrared eyes have revealed arcs of gas glowing with warm molecular hydrogen, a key ingredient for new stars. Instead of destroying this gas, the shockwaves are shredding it into smaller clumps, which could cool and collapse into new stellar nurseries. It's a cosmic paradox, destruction and creation intertwined in a single, breathtaking event. This quintet isn't just a pretty light show, it's a window into how galaxies evolve. Most galaxies, including our own Milky Way, have grown through collisions and mergers. These violent encounters reshape galaxies, spark starbursts, and scatter gas and dust across vast distances. The telescope's data shows gas bridges and tails stretching between the galaxies, hinting at dwarf galaxies or clumps of matter being torn apart. It's a reminder that the universe is a restless, ever-changing place, where even the most massive structures are shaped by chaos. By studying these interactions, scientists are piecing together the story of how galaxies like ours came to be, and what might await us when the Milky Way collides with its neighbor, Andromeda, billions of years from now. Closer to home, the telescope is rewriting the story of our own cosmic backyard. It's turned its gaze to star-forming regions like a nebula, where baby stars are born inside cocoons of dust. Infrared light pierces these clouds, revealing young stars gathering mass, surrounded by swirling disks that could one day form planets. It's a glimpse of our own origins, a reminder that our Sun and Earth were once part of a similar cosmic nursery. The telescope has also captured the death throes of stars, like a dying star, casting off its outer layers in a dazzling display. These images aren't just beautiful, they're clues to the life cycle of stars from birth to death and how they enrich the universe with the elements that make life possible. Even our solar system isn't safe from the telescope's scrutiny. It's peered into the hazy atmosphere of a distant moon, revealing methane seas and clouds of exotic compounds. These findings are fueling dreams of future missions, where probes could explore these alien worlds for signs of chemistry that might hint at life. The telescope has also studied gas giants in our solar system, capturing their turbulent atmospheres and faint rings in unprecedented detail. Every observation, whether it's a distant galaxy or a nearby planet, adds another layer to our understanding of the cosmos. It's a humbling reminder that the universe is interconnected, from the smallest moon to the grandest galaxy. The telescope's instruments are the unsung heroes behind these discoveries. Its near-infrared camera captures the stunning images that take our breath away, while its spectrograph dissects light to reveal the universe's chemical secrets. A mid-infrared instrument goes even deeper, spotting cooler objects like dust clouds and comets that glow faintly in the cosmic dark. Together, these tools create a multi-dimensional view of the universe, from the fiery hearts of galaxies to the icy surfaces of distant moons. Every observation is a testament to human ingenuity, to the decades of work by engineers and scientists who dared to dream of a telescope that could see the invisible. So what does this all mean for the future? The telescope's discoveries are just the beginning. Scientists are planning deeper surveys, targeting blank patches of sky to uncover more hidden galaxies. They're chasing the chemical fingerprints of the first stars, hoping to confirm whether the universe's early days were as wild as these images suggest. Others are studying the atmospheres of exoplanets, searching for signs of water or other molecules that could hint at habitability. These efforts aren't just about satisfying curiosity. They're about answering the biggest questions of all. How did we get here? Are we alone? What is the universe truly made of? The implications for cosmology are profound. If galaxies formed faster than we thought, it could mean the universe's expansion rate, known as the Hubble constant, needs tweaking. This could resolve a long-standing mystery where different measurements of the universe's growth don't quite align. Or it could point to new physics, like a different form of dark energy driving the cosmos apart. The presence of heavier elements so early also raises questions about how stars forge these building blocks. Were the first stars massive beasts that burned out quickly, seeding the universe with metals? Or is there an unknown process at work, something we've never imagined? Every answer leads to new questions, and the telescope is our guide through this cosmic maze. This discovery is also a call to action. The telescope's success has inspired engineers to dream bigger, designing future observatories that could dwarf its capabilities. Imagine fleets of satellites working together, or mirrors, even larger than the telescopes, capturing light from the universe's darkest corners. International collaborations like the one that built this telescope are paving the way for these ambitious projects. Meanwhile, the images pouring in are igniting passion in a new generation of scientists. Students are poring over these cosmic vistas, inspired to study physics, engineering, and computer science. The telescope isn't just a tool, it's a spark, lighting a fire of curiosity that will burn for decades. Let's take a step back and feel the weight of this moment. Humanity has always looked to the stars for answers. From ancient stargazers mapping constellations to modern scientists probing the Big Bang. This image, this single frame from the telescope, is a milestone in that journey. It's a reminder that the universe is stranger, wilder, and more beautiful than we ever imagined. It challenges us to rethink our place in the cosmos, to question the stories we've told ourselves about creation. Are we insignificant specks in an infinite sea of galaxies, or are we part of something grander, a universe teeming with possibilities? The telescope can't answer that yet, but it's bringing us closer than ever before. As we speak, the telescope is still out there, silently scanning the skies, collecting light that's been traveling since the universe was young. Each new image, each new spectrum, is another piece of the puzzle. Scientists are working around the clock, analyzing data, debating theories, and dreaming of what's next. The public is watching too, captivated by these glimpses of the cosmic frontier. Social media is ablaze with reactions, from awe-struck emojis to heated debates about what it all means. This isn't just a scientific moment, it's a human one, a shared gasp of wonder as we peer into the unknown. So what's the verdict? The telescope's latest image is more than a photograph, it's a wake-up call. It's telling us the universe is full of surprises, that our assumptions are fragile, and that the truth is out there, waiting to be uncovered. The physicist's words ring true. This is the most significant revelation of our lifetime. It's a challenge to scientists, a gift to dreamers, and a mystery for us all. The cosmos has spoken, and its message is clear: everything we know is just the beginning. Stay curious, keep exploring, and hold on tight, because the universe has more shocks in store, and we're only getting started. The cosmos has just dropped a bombshell so colossal, it's rewriting the rules of existence itself. The James Webb Space Telescope, humanity's ultimate window into the universe's deepest secrets, has unveiled an image that's not just stunning, it's a full-on assault on everything we thought we knew. The world's leading physicists, once tight-lipped, are now shouting from the rooftops about a discovery so earth-shattering it's sending shockwaves through the scientific community. This isn't just a picture, it's a cosmic wake-up call, a heart-stopping revelation that's forcing us to question the very laws that govern reality. Words like unbelievable, game-changing, and mind-bending are flying around, and for good reason. This image could unravel the mysteries of creation and propel us into a new era of understanding. So what's got everyone so rattled? Why is this single snapshot causing such a frenzy? Grab a seat, because we're about to plunge into the most electrifying cosmic adventure yet. Imagine staring at a canvas of the universe, a slice of sky so tiny it's like peeking through a pinhole. Yet within that minuscule frame, the telescope has captured a spectacle that defies logic. A swarm of galaxies, some so ancient, their light has been racing toward us since the universe was a mere toddler. These aren't just any galaxies, they're cosmic giants, packed with stars and structures that look like they belong in a much older universe. The kicker? They were already thriving just 300 million years after the Big Bang. That's not just early, it's absurdly early, like finding a fully built city in the Stone Age. These galaxies are bursting with complex features, spiral arms, central bulges, and even hints of supermassive black holes. Scientists are flawed because our models said this level of cosmic architecture should have taken billions of years to form. Not a cosmic nanosecond. This image is screaming one thing: the universe was playing by rules we never knew existed. Let's dive into the heart of this cosmic conundrum. The universe kicked off with a bang, 13.8 billion years ago, a chaotic explosion of energy and matter. In its earliest days, it was a swirling mess of particles, too hot and wild for anything structured to take hold. Gravity, the universe's master sculptor, was supposed to slowly pull matter into clumps, forming stars and small, scrappy galaxies over eons. But this image flips that story upside down. These early galaxies aren't scrappy. They're colossal, with star populations rivaling modern galaxies like our Milky Way. Even more bizarre, they're loaded with dust, a byproduct of stars living and dying over long periods. How could so much dust, so many stars, and such intricate structures exist in a universe barely out of its cradle? It's as if the cosmos hit the fast-forward button, and scientists are racing to figure out why. The telescope's infrared wizardry is what's making this discovery possible. Unlike any observatory before it, this cosmic beast can see light that's been stretched by the universe's expansion, light that's been traveling for over 13 billion years. Its massive mirror, glinting like a golden honeycomb, scoops up these faint whispers from the cosmic dawn. But it's not just about distance, it's about clarity. The telescope's instruments can slice through the haze of cosmic dust, revealing hidden details in galaxies that would have been invisible to older telescopes. In this latest image, scientists spotted faint smudges that turned out to be galaxies teeming with activity, their light carrying clues about their age, composition, and even their motion. These smudges aren't just pretty, they're cosmic fingerprints, and they're telling a story that's rewriting the history of everything. Here's where things get downright wild. When researchers analyzed the light from these ancient galaxies, they found something that sent chills down their spines: signatures of heavy elements like carbon, oxygen, and even traces of iron. In the early universe, stars were supposed to be simple, made mostly of hydrogen and helium. the primordial building blocks. Heavy elements, or metals in astronomer speak, only form inside stars over millions of years, released when those stars explode as supernovae. Yet here they are, showing up in galaxies that existed when the universe was just a fraction of its current age. This suggests an insane burst of star formation and death, a cosmic fireworks show that churned out these elements at a breakneck pace. It's like finding a fully stocked library in a village that just invented writing. Either our timeline is wrong, or something extraordinary was happening in those early days. The emotional impact of this discovery is impossible to overstate. For millennia, humans have gazed at the stars, weaving stories about our origins and our place in the grand scheme. We thought we had a handle on the universe's story, a slow, steady march from chaos to complexity. Now this image is forcing us to face a humbling reality. The universe might be far stranger, far more creative than we ever dared to dream. It's a gut punch of awe and wonder, a reminder that we're tiny specks in a cosmos that doesn't play by our rules. Yet it's also exhilarating. We're living in a moment where the veil of ignorance is being lifted, where every new image brings us closer to the truth. This isn't just science, it's a spiritual journey, a quest to understand the forces that birthed us all. Scientists are buzzing with theories to explain this cosmic curveball. One idea is that the early universe was a pressure cooker, with dense pockets of gas collapsing into stars at a furious rate. These stars, massive and short-lived, could have burned out quickly, spewing heavy elements into their surroundings. Another possibility is that dark matter, the mysterious stuff that makes up a quarter of the universe, played a bigger role than we thought. Dark matter's gravity could have acted like a cosmic scaffold, pulling matter together faster than our models predicted. Some researchers are even floating wilder ideas like primordial black holes, seeding galaxies, or unknown particles speeding up star formation. Each theory is a spark, igniting debates that could reshape physics as we know it. But the telescope isn't just rewriting the past. It's shedding light on the present in ways that make your jaw drop. Take a cluster of galaxies caught in a cosmic pile-up. Their gravitational dance creating a scene straight out of a sci-fi epic. The telescope's infrared gaze has revealed shock waves rippling through the gas between these galaxies, compressing it into glowing arcs that pulse with potential. These arcs aren't just pretty, they're star factories, where the chaos of collision is birthing new suns. What's astonishing is how these shock waves are recycling gas, turning it from hot to cold and back again, like a cosmic engine. This process could explain how galaxies keep forming stars long after their initial burst, a discovery that's turning our understanding of galactic evolution on its head. Then there's the telescope's knack for uncovering the unexpected. Point it at a random patch of sky, and it finds galaxies that defy categorization, some with bizarre shapes, others glowing with an eerie intensity. One recent observation revealed a galaxy with a double nucleus, a sign it might be in the midst of devouring a smaller neighbor. Another showed a faint, elongated streak that could be a tidal tail, the stretched-out remains of a galactic merger. These findings are painting a picture of a universe in constant flux, where galaxies are born, clash and transform in a never-ending cycle. It's a cosmic soap opera, and the telescope is giving us a front-row seat. Closer to home, the telescope is peeling back the mysteries of our own solar system with a flair that's nothing short of spectacular. It's zeroed in on a distant, icy world, capturing images of its surface that reveal shimmering lakes of methane and clouds swirling with organic compounds. These aren't just geological curiosities. They're clues to the chemistry that might have sparked life on Earth billions of years ago. The telescope has also turned its gaze to a gas giant's turbulent atmosphere, revealing storms and auroras in stunning detail. Even the planet's faint rings, usually lost in the glare, pop into view, their icy particles glinting like cosmic jewelry. These observations aren't just beautiful, they're rewriting the playbook for future missions to explore these worlds. The telescope's tech is the real star of the show. Its near-infrared spectrograph is like a cosmic detective, breaking down light to reveal the secrets of distant objects. Want to know what a galaxy is made of? The spectrograph spills the beans, showing peaks and dips that betray the presence of specific elements. Its mid-infrared camera, meanwhile, is a master at spotting the cool, dusty corners of the universe, from comet tails to the hearts of star-forming nebulae. And let's not forget the fine guidance sensor, which keeps the telescope locked on its target with precision that borders on miraculous. Together, these instruments are turning raw data into a symphony of discovery, each note a step closer to unlocking the universe's deepest truths. What's next for this cosmic juggernaut? Scientists are already planning ambitious campaigns